Now let's take a look at the entire process using a graph. We'll start with the resting membrane potential, go on to the local potential, followed by the depolarization phase of the action potential, repolarization phase of the action potential, and back to the resting membrane potential. On this graph, on the x-axis, we have time in seconds. On the y-axis, we have membrane voltage in millivolts. We have -70, -55, 0, and +20 millivolts. At -70 millivolts, the neuron is at rest. We have the resting membrane potential. This stays the same until a new impulse arrives. When an impulse arrives, ligand-gated sodium channels open, sodium rushes in and causes a depolarization. We call this stage the local potential. The range of the local potential is from -70 millivolts to -55 millivolts. When the voltage reaches -55 millivolts, we call this the threshold voltage, it triggers the opening of voltage-gated sodium channels. Sodium rushes in and causes a depolarization, raising the voltage to +20 millivolts. At +20 millivolts, voltage-gated potassium channels open, potassium rushes out, causing the repolarization. The repolarization is so fast that it actually dips a little bit below -70 before the resting membrane potential is restored. So we have 5 stages in this whole process. The first stage is the resting membrane potential. When an impulse arrives, we have the local potential, which is stage 2. When the local potential reaches -55 millivolts, it triggers the depolarization phase of the action potential, which is stage 3. When +20 millivolts is reached, it triggers the repolarization phase of the action potential, which is stage 4. The repolarization goes all the way down and below the resting membrane potential, and we call it the hyperpolarization, which is stage 5. This stage is very temporary when the resting membrane potential is quickly restored. So let's take a look at what happens at each junction. We have A, which is where ligand-gated sodium channels open. B is where voltage-gated sodium channels open. C is where the voltage-gated potassium channels open. These are the main events of the nerve impulse transmission. So let's review these one more time. Stage 1, resting membrane potential. And the voltage is -70 millivolts. Stage 2 is local potential, going from -70 millivolts to -55 millivolts, triggered by the opening of ligand-gated sodium channels. Stage 3 is depolarization phase of the action potential. It ranges from -55 to +20 millivolts, triggered by the opening of voltage-gated sodium channels. Stage 4 is repolarization phase of the action potential. It ranges from +20 to -70, or maybe even lower. Stage 5 is the hyperpolarization. It is a very temporary state when the action potential is recovering back to the resting membrane potential.